Hello, Year 9s. Welcome to Mr. Chen's classroom again. How are you guys? This will going to be the second to last videos for coordinate geometry. So, in this lesson, we are going to talk about the equation of line, which is also called aka the linear equations. Okay, so the learning lesson objective is by the end of this lesson, you will know how to write a linear equation and know what it means. Okay, linear equation is probably one of the easier one compared to like quadratic equation, which is quite a lot harder. So let's begin. So when you look at linear equation formulas, it's actually the grand total of what you have learned from the last few videos. So last few videos we talk about how to label your Cartesian plane, which is right here. All right, this is your Cartesian plane. And we also went through what's your x and y coordinates, and we also learned how to find the distance between two coordinates, and we also learned about how to find midpoints, how to find gradient. So for those who forgot, gradient is the slope of a line on the Cartesian plane. Okay, and we also went through how to find the x-intercept, which are your x and y-intercept. Okay, and x-intercept is the coordinates where the line passes through the axis, and y-intercept is the coordinates where the line passes through the y coordinates. Okay, so that's for y-intercept. So linear equation formulas uses all of those knowledge. Maybe not the midpoint, but definitely gradient, x-intercept, and also your coordinates. So this, let me present you the linear equation formulas. Y equal to mx plus c. Let me explain each of them what that means. So y and x here pretty much referring to the y coordinates of one specific coordinates. Okay, one specific coordinates on the line. So let's say if I drew line like this, if I drew a line, straight line, sorry, it's not the straightest, but it should be fine. Okay, so I draw a line here. So that line passes through -4 on y-axis and passes through 4 on x-axis. Okay, so what that means is this x and y coordinate has to be on one point of this. Okay, at any point on the line, any coordinates, okay, you can use the x and y coordinates of one of these points. Okay, there are more of them, I only drew point out a few. You can actually put those, pick one of the coordinates and put the x and y in, and it should form the linear equation, and you will be able to check your linear equation whether it is right or wrong by putting one of these coordinates on the line. Okay, so and we have m is your gradient, and gradient is used to measure how steep is a slope. Okay, so here we have a linear equation, and the slope there, that's what the gradient is. Okay, how slopey it is. obviously the higher the number, the more slopey it is. And remember, we have a positive gradient and negative gradient. Positive gradient is like one of these. That's a positive gradient. And the negative gradient is actually one that goes down. Okay, that's a negative gradient, which is a negative linear equation as well. And next we have C. C is your y-intercept. Okay, y-intercept, like I said before, is a line, it's a coordinates that allows the line to pass through the y-x intercept. That's y-intercept for you. So in this situation, that is our y-intercept, which is -4. Okay, so -4 is the y-intercept for that specific line, for that specific linear line with this linear equation as well. Okay, so that's what it means. And one thing that I want to point out is this linear equation, right? Remember, all the points on there, all the coordinates on there, on that line will, if you use each of them to test out this, it will actually satisfy this y equal to mx plus c. Okay, I will actually explain what it means later. So let's show you a few examples of how it looks like in actual form. So we have y equal to 3x plus 7. Okay, so from there you straight away can tell that the gradient is 3 and the y-intercept is 7. Okay, so what that means is this line, this linear equation connect the x and y coordinates of every point on a straight line. At any point, the y coordinates is 3 times the x, 3 times the x coordinates plus 7. Okay, so this is the interpretation of this linear equation. The y coordinates, like I mentioned here, that's the y and that's the x. The y coordinates is 3 times the value of the x and then plus 7. So for example, if x is, we just give an x of number. For example, if x is 2, what that means is y is 3 times the number of 2 and then plus 7, which will be 3 times 2 is 6, 6 plus 7 is 13. That's what it means. So look at this, for example, does that resemble that? Look at that. Sorry. What does this kind of remind you of this? Look at this. What I did was, if x is 2, I literally put the 2 into here, and then you will be able to find the value of y. Okay, that is how useful the linear equation is. It helped you to actually find the x and y. It also allowed you, if you have the coordinates of the coordinates on the line, you will be able to find the linear equation which is including the y-intercept. Okay, so I'm gonna erase that. You can go back and have a look at it yourself. Pause the video, rewind it, because I need to move on. So let's move on to the next bit. So to test that, I'm gonna write something down here. Determine whether the point three and 4 lie on the line y equal to 2x plus minus 2. So we're now gonna test whether 3 and 4, which is the coordinates, is in the line. If you remember correctly, like I said before, if the line, if the y equal to 2x plus 2 is correct, is the line that passes through at one point at the 3 and 4, the coordinates, if you put the number in, the coordinates into that equation, you should be able to get the answer. Okay, you should be able to see that, which I'm gonna prove you here. So what that means straight away, you're gonna have to see which one is x and y. This is the x and that is the y. Okay, remember x first and then y always, it coming after that. So now that I have given the identity to 3 and 4, all I need to do is put that into this. So what it means is put it on to here. So 3 equal 3 is the y now. Okay, y is the 3 now. Okay, y is 3 now. 2x, x is 3 minus 2. Okay, so literally all you need to do is plug in the number. Okay, the reason why I put bracket there, it means multiply. Okay, so now I have 3. So both sides should be 3 at the end. Okay, so that you actually can solve the equation. So 3 equal to 2 times 3 is 6. 6 minus 2. Okay. What you will see here is 3 equal to 4, which is not. Okay, which is not. 3 is not equal to 4. So what this means is the line, the coordinate 3 and 4 does not lie on the line y equal to 2x minus 2. Okay, that is the conclusion. That is what it means. Okay, so let me show you another one. Hopefully the next question is going to be if it is a lie on the point on the equations. So the next one we have, see whether minus 2, 10 lies on the line y equal to minus 3x plus 4. Okay, so here we have x, which is minus 2, and y, which is 10. So I'm gonna put that in. All you need to do is put that in. Y now become 10, and negative 3 still the same. X now become negative 2, and then plus 4. Okay, so let's see. So 10 equal to, write it down, negative 3 times, remember this means time, negative 2, which is 6, plus 4. Okay, so 10 equal to 6 plus 4 is 10. So 10 equal to 10. So what that means, if both sides are the same, that means these coordinates lies on that line, which on that equation. Okay, so in conclusion, minus 2, 10 does lie on the line y equal to negative 3x plus 4. Okay, so that's what it means. So congratulations, we went past the first part, and I will actually tell you how to actually do your own linear equation in the next videos. Alright, because I think I went a bit over in this one. Good job guys for listening, and stay tuned for part 2. Peace out, bye.